Welcome back to Cloud42, I'm James. In a recent video, I set up mist coolant on my new surface grinder, and in that video I did a little bit of test grinding on some mild steel, and while it worked fine and the surface finish was better than I could get on the mill, there were some artifacts visible in the finish. Many of you weighed in the comments section telling me I needed to dress the wheel, and I did actually do that, but I didn't show it in the video, so I guess by internet rules, it didn't happen. But a few people said that I'm getting that surface finish because I need to balance the wheel. So I guess now we need to make a wheel balancer. The wheel I used in the last video is still mounted here on the grinder, so the first thing we need to do is take it off. The wheel is mounted on a wheel adapter, and the wheel adapter is mounted on the spindle of the grinder with a lock nut. Now, this gets very confusing because in this particular style of grinder, because the wheel is turning clockwise, it is a left-hand thread on the nut. So you have to turn it to the right to take it off. Don't ask me how many times I've screwed that up. Now, it's still stuck on the taper, so the wheel adapter comes with a little cap that threads into the adapter itself, bears on the end of the spindle shaft, and allows you to unlock the taper. It just takes a little bit of force, and it pops right off. Now I have a wheel adapter for every wheel in my shop, which right now is about 3 wheels. But the reason for that is so that the taper in the wheel adapter will stay concentric with the wheel because the wheel's never dismounted. And that allows me to take the entire assembly with the wheel adapter and the wheel, take it off the grinder, put it back on, and have it retain concentricity. So these are not super cheap. These are like $100 a piece or a little bit more. These particular ones I really like because in addition to having all the ground surfaces to precisely mount the wheel, they also have a set of 3 sliding weights here in the back that are used to balance the wheel without having to modify or cut anything. Now, these are just set into a groove and they're locked in place with a set screw. If you loosen the set screw, they just lift right out. And you can see the way these work, the set screw is just in a bore and there's a little ball bearing in here and it just pushes that bearing out, makes it wider, presses against the inner hub face and locks the weight in place. It also presses the weight against the outside circumference, which is the direction it's going to try to fly when the wheel spins, so it should be nice and stable once these are in the correct position. Now, of course, to get them in the correct position, we need a way to measure the current balance of the wheel, and that is done with an arbor. This one came with the grinder. If you just go out and buy these, they can be pretty expensive, and this one is not great. I can see that the surface of the taper here isn't totally clean, so I would like to stone that before I use it. Got some precision flat ground stones here. These ones are from Kinetic Precision. I'll just dress the stones against each other to make sure there's nothing stuck to them, and then just gently roll the taper, slide the taper along the top of the stone. And I can just feel if there are any scratches, there's any raised material, any dings. I can feel that and get this taper perfectly smooth without really taking any material off of it. And honestly, I'm not feeling anything here. Whatever I was seeing was just, I guess surface imperfections. I can't feel anything. So let's go ahead and seat this in the taper in the wheel adapter. And then once we have it in there, we have a shaft we can use to balance the wheel and see which side is heavy and adjust the weights accordingly. Now we do need something to set this on to roll, and of course the cheap and cheerful option is just to grab a couple of 246 blocks, set them on a level surface, and set the wheel on top of that, and you can already see this thing is rolling because it is out of balance. Now you really have to have these blocks level for this to be precise. This wheel's so far out of balance that it's easy to see, but once you get closer, they really need to be level. And in case you didn't know, nothing in my shop is level, and it's likely never going to be, so I really would like to explore some other options. If we go out to the usual places and search for grinding wheel balancer, we get, just a wheel hub. But if we look in the related products, we see a wheel balancer. This is the Sopco balancer. This is sort of the balancer that everybody thinks of when you think of a grinding wheel balancer. You can see it's just a casting with a couple of hardened rails on top that the arbor rides on. And then there's a set screw down here in the base for leveling it. There's a little spirit level. I don't really know how accurate that's going to be. but you could easily judge the level just by looking at how the arbor rolls. But $629, that's quite a lot for what it is. And I'm not entirely sure what it comes with, because they actually charge $420 for just the arbor itself. So I've seen some listings that say it doesn't come with the balancer. I've seen some that say it does. I'm not really sure. You can see here's an interstate one with basically the same design, but there's another design that's prevalent out here, and that's these ones with wheels. Now, these have hardened wheels, or at least metal wheels with a fine edge on them set in bearings, so you can set the arbor in them and it can rotate freely. But this is a little bit larger scale, I think. I've seen some of these that say they're rated for 1,000 pounds or wheels up to 96 inches in diameter. So I don't think this is what I'm looking for. I would be worried that a small wheel would actually be able to move freely enough to register a small imbalance. Now, Tormach used to have a CNC grinder that they sold, and they still have the accessories for that. They're quite a bit cheaper. Here we're looking at just over $300 for the typical kind of rolling rail style balancer, and they actually sell an arbor with a nut on it for just under $100. So that is the best deal I've seen. I haven't even seen very many of these used. So if you know of a great source for the arbors, let me know. There are some examples of shop-built balancers out there. If you go to the Kinetic Precision website, it's the second time I've mentioned them today, they do have a product here. Spencer has this balancing ring that he makes and sells, and if you scroll down and look, there's a photo in here of a shop-made balancer with a couple of bearings on here. Now, I actually had a conversation with Spencer about this, and he told me that this was an experiment that didn't really work out. The bearings just have too much friction. It's just not really suitable. But this is an idea that's really fascinated me, and it's something that I actually would be interested in trying. But of course, maybe I'll just learn again why it doesn't work. If we go out to Google and search for a wheel balancer, there's one hit here that I found kind of interesting. And that's this one, the Dubro TrueSpin Prop and Wheel Balancer. Now, this is a little plastic device that's used for balancing propellers and wheels for radio control vehicles, but I actually have one of these, and I've played with it quite a bit, and I think there are some design elements here that are instructive that might give us some clues for how to actually make a larger scale one that works effectively for surface grinder wheels. This is my prop balancer, and it is indeed a genuine Dubro branded prop balancer. This is probably considered vintage by today's standards. I bought it at a local hobby shop many, many years ago. I've got a prop here that I have balanced previously. It's just held on the shaft with a couple of cones and a spring pinching it in the bore. We can just set it on the rollers and give it a spin, or don't give it a spin. This prop is previously balanced. You can see all of the tape and glue on it. This is one that I just pulled out of my stash. It's one that I had not flown, obviously, because the balance was so bad. I just kept it as a backup. You can see in this case I used Kapton tape and a big blob of super glue on the side of the hub. Good news, gravity still works. This particular prop has all the weight on one side because the prop itself is actually bent, probably a defect in the molding or the cooling process, but I just have it here for illustration. Now, the wheels in here are quite a bit larger than you might expect. You can see they extend down. You can see them. They're visible in the openings on the sides. These are probably a couple of inches in diameter, maybe 50 millimeters. And the little pivot pin that they ride on is probably a millimeter, maybe even a little bit less. And that gives it a lot of mechanical advantage so that the friction of that pin doesn't affect the rotation of the wheel very much at all. So then when we set the shaft on top of it, the shaft itself is very, very small in relation to the size of the propeller. So weight placed way out at the end of the propeller has a tremendous mechanical advantage between the diameter of the propeller and the diameter of that shaft. So even just a tiny bit of tape stuck on this propeller will cause that blade to sink. You essentially have a two-stage mechanical advantage from the tip of the propeller blade all the way to the small diameter of the shaft. And then the second stage of mechanical advantage is from the outside rim of this large wheel to the very tiny pivot pin in the center. So the friction on that pivot pin presents very little resistance to the rolling action out on the rim of the wheel. And then, of course, the tiny, tiny shaft going through the propeller then presents very little resistance to motion all the way out at the tip of the propeller. Now, if I want to make something similar to this, I need some material for the side plates. I've got some aluminum here that came out of my scrap bin. This is about 3/8 of an inch. This should be plenty strong for the support for the bearings and the wheels. For the wheels, I've got a piece of 1144 stress proof. This could be turned down pretty easily to make a relatively large diameter wheel for the arbor to roll on. There would be quite a bit of turning, would have to remove quite a bit of material, but I think this would be big enough to give enough mechanical advantage. If we wanted to go bigger, we could use sheet material. Got some aluminum sheet here. I think that's probably what the wheels in the Dubro balancer are made from. We just have to figure out how to cut it out and how to smooth the edges and get them really concentric with the bearings. For bearings, the standard for hobbyists the world over are these 608 skate bearings. These are readily available, and I used a couple to make my bearing bump tool for the lathe. Now, these actually have a fair bit of resistance because they're greased, so there's a lot of drag. They probably would not be suitable for this, but you can clean them out, or you can actually buy dry, full ceramic bearings. These are from my stash from my fidget spinner phase, and if you thought it was only school-age children that went through that, all of us engineers did too, and we were making these things left and right. These are dry ceramic bearings, so ceramic races and ceramic balls, and these things are very low friction and will spin basically forever. And I think something like this ought to make a really good bearing for a balancing fixture, assuming it doesn't immediately fill with grit and start jamming up. Now, you do have to be a little bit careful with these because if your bore is out of round at all, or if the bearing fit is too tight, it's pretty easy to crack or damage these, but I think we can manage. You know, though, as long as we've got this prop balancer sitting right here, it is about the right size for this shaft. And it does roll pretty freely. Can you think of a good reason to not try this? Because I can't think of a good reason to not try this. Let's not try this. It seems to support the weight. It is moving. Let's see how the action is. I may have bumped it there a little bit, but it sure does seem to be rotating under its own imbalance. I think this might actually work. See if we can find the high spot here. So that's rolling that direction. Let's go the other way and see if it returns to the same place. And it does. Go ahead and mark the high spot here so we know what we're working with. And then let's start moving some weights. So that's the light spot. So we just need to move a couple of the weights towards that to move some of the weight in that direction. I really have no idea how much this is going to take, so I'm just going to use intuition and guess, and then we'll check and correct as we go. And it popped off the taper again. This thing really does not hold very well. I'm not convinced this thing is ground properly. I may get another one. I may try to regrind this one. We'll see. And that looks very promising. So you can see what was previously the light spot there, the little dot. And as I move that around into different positions, it's really not moving much. Now, we probably have a new light spot. There's just less force on it. You know, there's a little bit of movement there. Let me keep fiddling with this a little bit and see if I can find where the new light spot is. Maybe I just got lucky and this thing is pretty well balanced. Maybe we're dealing with a little bit of extra friction here. It's probably worth kind of adjusting things here and just trying to make sure that the wheels aren't being pushed against the sides of the plastic. This thing wasn't really designed to stand up to this kind of weight, even though it does appear to be working. Yeah, there is a little bit of motion. See if we can figure out where it's greatest. Yeah, right there looks like the greatest point, meaning it's heavy on the right-hand side. So let me go ahead and move this weight on the top back slightly, just to move some of the weight away from that. Pop it off the arbor again, of course. And see where we ended up. Now, if we drop the wheel on the ground, the good news is we won't have to balance it. We'll just have to buy a new wheel. Well, I'll fiddle with this a little bit more, but this looks pretty good. I think it's probably about time to take this over and try it on the grinder and see if the balancing made any difference. I do know it's balanced better than it was. Is it balanced as well as we could get it with a better balancer, with a hardened rail rolling jig that was leveled properly? I don't know, but I'm willing to give this a try because this is nice and cheap and easy. Let's mount this up and see what happens. Installation is, of course, the reverse of removal. We'll just put this on the taper and lock it down with the nut. Now, the fit on the taper here is much, much better than on that arbor, so I'm pretty sure that there is a grind issue with the arbor, but the spindle on the grinder is just fine. Now, to tighten this, I could hold on to the wheel and give the nut a good snug, and I'll give it a little light snug that way, but I don't want to put any real gronk on it because there's a risk that the wheel will slip underneath the blotter, or the blotter will slip on the adapter, and then all the concentricity that we worked so hard to preserve would be lost. So I will hold the square end of the shaft to tighten it, put the guard back on. I want to see the wheel spin as much as you do, but not at the risk of personal safety. Power up the rotary phase converter, let it stabilize. Smooths right out after a few seconds, and we'll turn on the spindle. By just putting my hand on the guard here, this already feels smoother. I could feel a little bit of vibration in it before. I wasn't sure if that was normal, but I am feeling quite a bit less. I know this is not a scientific measurement, but our fingers are pretty sensitive, and this really does feel like it's running smoother to me. Could be confirmation bias, of course, so let's find a suitable victim and do some grinding. But first, we're going to dress the wheel. This is a little single point diamond dressing tool. Also came with the grinder. We'll just stick that down on the magnet and work that over under the wheel. Now the wheel's actually quite a bit higher than this. I'm not going to feed it in and crash it, don't worry. I also have this positioned now so that it is just past the center line of the wheel. I know it does not look like it from this camera angle, but if it does grab, it'll just push it out of the way. And I'll just lower this. I'm feeling with my hand for the first hint of grit coming off the wheel. I just felt that. We'll sweep across, and I'll just bring it down a thou or two at a time, take a couple of cuts across the wheel, and smooth it out. It was already dressed, it was already in pretty good condition, so there isn't a lot of material that needs to be removed here, but we'll just expose a nice, fresh, sharp edge so we have our best chance of getting a good grind. Now we need a suitable victim, and I found these in my toolbox. You'll probably recognize these from a video I did in 2017 when I made them. These are some shop-made Talon Grip clone vice jaws, and they just have a milled finish. So let's work this down, find the surface, and start grinding. Now I just was pulling it down very gently as I moved back and forth until it touched. We'll turn on some coolant mist here, and we'll just take a pass. Okay, it's a little bit heavier on the left-hand side there, but it doesn't seem like it's more than maybe a thou, so I think we're going to be fine. We'll go ahead and work our way across unless it starts getting real heavy. This cut is not quite cleaning up. I think that means that this was not parallel off the mill. I know, shocker, I just did this on my little grizzly mill, but it looks like it was within maybe a thou of parallel. Go ahead and finish, and you can see it's not cleaning up on the right hand side. So we'll make another pass going back the other direction, taking about another thou, and this now does appear to be completely cleaning up all the way across. The goal at this point is just to get a parallel, not to really push hard on the surface finish, and then we'll come back and take another tenth or two. Now, keep in mind, I am not an expert in grinding. I literally just got this machine. This is my first experience with a surface grinder, so I am learning as we go. So I took a tenth or so all the way across, and now I'm just taking essentially a spring pass, letting it spark out, going back the other direction, and then we'll pull it off and take it over the bench and see what kind of finish we got. It looks pretty good here. It's not perfect. This is mild steel, so it's probably not ever going to look really beautiful, but let's go ahead and pull this off the magnet, take it over the bench, and take a closer look. So what do you think? Is this better than what we got last time? I honestly don't know. I think it is a little bit better, but I could not find the other piece. I went and tried to find the piece. I'm not going to unbalance the wheel again to do a comparison. I have really no idea what I did with that. I was going to put them side by side. I was really excited about it, and now I can't find it. The finish isn't as great as I had hoped, but it is mild steel. Is it just the wrong material? Am I using the wrong wheel? Is the balance really not sufficient? Is my technique wrong? Am I using the wrong coolant? Yeah, probably all of those things. So feel free to jump down in the comments and give me some pointers. I'm always interested in learning. Keep it constructive, so that we can all benefit from it. But honestly, it doesn't look too bad. Now, I know that the whole purpose of grinding is for dimensions, and we'll get to that in future projects. But boy, you put this thing side by side with the milled one, yeah, that looks pretty good. I'm pretty happy with that. I think I'm to the point here where I've kind of got my muscle memory so I can operate the grinder, and it's time to put this thing to work doing something real. It certainly does look better than what I achieved on the mill, and honestly, I thought that mill finish looked pretty good for 1018 mild steel. So we're on our way. Just keep plugging.
I honestly can't believe that worked. These plastic RC prop balancers are really inexpensive. The Dubro brand one that I have is one of the premium ones, but it's still just a fraction of the cost of the Sopco or even the Tormach balancers. I'll put a link in the video description if you're interested, but be forewarned, I have no idea how long it might last in this application because it is definitely not what it was designed for. I still kind of want to build a nice one, but I guess you'll have to subscribe to see if I ever decide to do that, or if I let it get lost in my ever-growing pile of ideas for things to play with in the shop. If you enjoyed this or found it useful, give it a thumbs up. Maybe consider supporting the channel over on Patreon. And if you're already a patron, thank you. You're the ones that make all of this possible. Thank you for watching.